is MEI Statistics Minor, Bivariate Data 2, Correlation Coefficients. 2.2, Hypothesis Testing using the Product Moment Correlation Coefficient 1. So, to remind you, Pearson's Product Moment Correlation Coefficient is a measure of the linear correlation between two variables. Often we'd like to test whether the correlation is statistically significant. In this case, we will use a hypothesis test. However, it is only appropriate to do a hypothesis test on Pearson's Product Moment Correlation Coefficient when four modelling assumptions hold. The first is that the data must be random on random. The next is that it must be drawn from an approximately bivariate normal distribution. Now, the exact definition of this is not required, but it's sufficient to know that if the following hold, then it is likely to be a bivariate normal distribution. The scatter diagram is roughly elliptical, with data points more concentrated at the centre, just like in a normal distribution where the data points are more concentrated at the centre near the mean. Data points are roughly symmetrical within the ellipse, and neither variable is bimodal or skewed. So, example 1, for which of the following scatter diagrams is the assumption of bivariate normal distribution a safe one? The first one, we've got a rough elliptical shape around here. We can see that in the centre it's more densely populated than on the outside. I'd say that that is a safe assumption. The second one, though we have a rough ellipse around here, they are not concentrated near the centre. We have a bimodal distribution here. So that is not a safe assumption. Here, I would say the data is quite severely skewed. We've got a lot more data points here than we have over here. So that is not a safe assumption. Assumption 3, the data is not nonlinear. Now I've phrased it in that way because it doesn't necessarily look like a line. It doesn't necessarily look as we would associate linear to be. But it should definitely not look nonlinear. We should use a scatter diagram to determine this visually. So for instance, this scatter diagram is certainly not linear. It looks like it has a curve, so that is non-linear. No good for our test. This one, we could consider the main sequence here to be roughly linear, although it does have a curl at each of the ends, but there are all these other stars outside the sequence that are forming different pattern, so I would say that is not a safe assumption either. Assumption 4, there are no outliers, and again we want to use a scatter diagram to determine this visually. So just to show how badly an outlier can affect Pearson's Product Moment Correlation Coefficient, we have a set of data here with x values and y values, and we have Pearson's Product Moment Correlation Coefficient equal to 1. In other words, there's perfect positive correlation, as we can see from this scatter diagram. If, however, I add in an outlier, 12, 7, and recalculate, you can see that this single outlier down here has changed that from 1 to minus 0.2. So it is now indicating a negative correlation. Each of these datasets have the same value of R. For which of these would a hypothesis test on the Product Moment Correlation Coefficient be appropriate? Well, the first one, that's almost certainly nonlinear. In fact, I would say that's probably quadratic. So that one's no good. The second one, we've got a very obvious outlier here. So that wouldn't work. Again, the third one, we've got an outlier here. No good. The fourth one is the best looking candidate, but if you look very carefully, all of the x coordinates are on well-defined points, and there is only one on each of these vertical lines. This suggests to me that this is a controlled experiment, so this is random on non-random, which is again no good for us. And if you look very carefully, every single one of them is also random on non-random. So that would be another reason not to choose them. Next, we're going to be finishing hypothesis testing using the product moment correlation coefficient.